Hey guys, Chess Research here, and today we're going to be upgrading this electrolyzer. If you guys wanted to see that, stay tuned. This right here is an aluminum check valve. I don't recommend using aluminum check valves. You can see I've got this way far away from the electrolyzer, but you're supposed to use something odd of stainless steel, and I always recommend stainless steel over aluminum. So you want to use stainless steel. It doesn't really matter what kind of grade stainless steel you're using on parts like ball valves and T's and elbows. If you don't feel like spending the money on stainless steel, these plastic elbows work great. Just be sure and make sure that they're threaded in correctly to avoid leaks later down the line. This right here is a large leak we've had on the electrolyzer, and it's got epoxy on it right now. We're going to have to weld this later. Now it's time for a little bit of ASMR of me taking this thing apart, because it took a hot minute to get this thing apart. If you guys want to skip this part, go to around 3 minutes. That's where I get done dismantling this thing. Now with all of that out of the way, let's talk a little bit about plates. You can see here on this plate where the original electrolyte was, we like to fill it up about 3/4 of the way, so to avoid arcing or anything like that. These here are our new plates. They're 3/16 stainless steel. They're .12 gauge, which is very thin. In comparison to the original plates, it is very, very thin. And cutting these things out was a headache, but it was worth it in the long run. This can help with heat and also the production of hydrogen and the consumption of the electricity in the system. And overall, this is going to be a pretty big upgrade for this thing. I ended up using a piece of wood here, as you can see, sandwiching in the piece in between it, making it a whole lot easier to cut this steel. I was using a stainless steel cutting wheel here, absolutely slicing through this stuff like butter. Be sure and get a stainless steel wheel, it makes it a whole lot easier. All of these are going into a 60-cell electrolyzer, so I ended up cutting out about 65 of them, just in case. It's always good to have extra. Next thing we're going to be doing is cleaning the edges up on these things, getting rid of all the jagged edges. As you can see, I have a piece right here that I've already grinded up a bit. You want to avoid pointy edges with these plates because pointy edges equals arcing. Pointy edges conduct electricity a lot better than rounded edges. Here I am sandwiching these things together, and just to avoid all the curves in them, to make them a little bit flatter, because we want the gap in between them to be as accurate as possible. As you can see, they're extremely thin and very easily bent. Putting them in a press can make a big difference. This next part, we want to be extremely careful. This is just battery acid that you can pick up at your local automotive store. I'm wearing gloves here and a mask because this stuff is not good to breathe in. We're going to leave this thing for about 24 hours to off gas. So you want to have this thing in a open area so it can off gas and do its thing. And you want to keep it away from any pets, animals, or anything like that. And you really do not want to breathe this stuff while it's doing its thing. The acid is going to be taking off the metal oil, because every metal, when it comes from a shop or somewhere that manufactures metal, they're going to have a slight oily residue on it. And we want to remove that so we can improve the electrical conductivity of the plate. This right here is a plastic sheet of HDPE plastic, and it's being used to hold all of the cells together. And it also does a pretty good job of absorbing heat and is a pretty good insulator as well. So we ended up using it. So we used a table saw to cut a 3/8 gap in between each cell, and these are held in here pretty snugly. As you can see, I'm having a hard time pulling these two out. You want very little gap in between the cell or the plate and the HDPE plastic so the water doesn't seep through and it has less of a chance of running electricity through it. And so it has to travel through the plate to create the electrolysis instead of just, bypassing it by going around the plate. The original plates that I'm pulling out right now, they have small holes drilled in them so the water can seep through, and that's the only way that the liquid in the electrolyzer can move through each plate. It makes it where the electricity has to flow through the plate. And with the new plates, they're going to be a little less snug in there. They're going to be a little more loose because of how thin they are. And so we're not going to be drilling holes into the thinner plates. I cleaned up on this thing quite a bit. Some rags and a water hose. And I sprayed it out to clean it out a little bit. We had a couple of explosions. They were small, but they ended up ruining some of the mixture of the electrolyte. And so we had some rust in the system, so that's what I'm cleaning out now. And overall, it runs very clean, even though the outside shell of the electrolyzer is not made of stainless steel. It is, I believe it's just regular forged steel, and we had very little rust, so it did a pretty good job, honestly. 24 hours later, and this is what we have now. You can see that some of the plates are black and some of them are silver. This bin is almost acting like a battery. You can see the bubbles on the side of the bin wall, and it's acting like a battery, I guess, because of each cell acting as a negative and a positive. And as you can see, I'm wearing some pretty heavy safety gear right now. This stuff is just, it's not really good for your eyes or to breathe. Be sure and wear a mask or something. I believe I'm wearing a gas mask right now with full eye protection. And I'm just wearing my regular civilian clothes because I'm not trying to get this stuff on me. Also, having some sort of a water source nearby, doesn't matter what kind of water it is. This hose water works fine, but it does a pretty good job of diluting the acid. Make sure you don't get this stuff on you. It's not good to breathe, and it's not good to get on your skin for sure. But basically, I'm going to be taking these plates and scrubbing them. A brass brush, and then I ended up using a power drill brass brush to get these things back to their stainless steel chrome color. And as you can see, they're black like a coal, and it's pretty hard to get this coating off, but it makes it where it conducts electricity better, and in turn you get more bubbles and less heat. So this is a really important step. Note, some of these are positively charged and some of these are negatively charged just by being in the acid. As you can see, all of this picked up, all of this is oil, which is going to be a pain in the butt to scrub off. Okay, I know I'm not the best at welding, but this thing just kept leaking, so we ended up putting 3 layers of weld on it, and it looks absolutely grotesque, so you guys can roast it in the comments all you like, but it's doing the job at least. I really don't like using my camera around when I've got paint because of backsplash and a lot of other reasons. But I messed up that first stroke and put a big fat run right through that paint because I was looking through my camera. These two holes in the front right here are for the sight glass, and then these other two holes are for the gas exit and the check valve. This top prevents it from having a lot of foamage, because a lot of electrolysis devices, they tend to foam up a lot, especially the smaller the confined space is for the electrolysis. We drilled holes all over the top to make the top act as a diffusing plate, diffusing the bubbles, making it where the gas can exit, and also so electricity doesn't arc to the outside shell of the electrolyzer. I'm using the stainless steel screws to hold it down. These are very, very small. The head of my screwdriver keeps slipping while I'm trying to drive these things in. Right here I'm working marine grade epoxy, and I'm going to create a seal for the new electrolyzer end caps. I don't know if that's the correct term for them, but that's my coined term, I guess, for them. But I'm going to use this epoxy to seal the plates, and to make it where we have a connection point for the end plate to be positive and negative. So I'm going to end up having to do this twice. So I made up quite a bit of epoxy here, and I'm just going to spread it around the end cap so I can put the HDP plastic and basically sandwich it together with the plastic, and create a watertight seal, and also to kind of prevent the outside plate and the bolt that exits the plate from arcing to the end plate. I know that's a mouthful, but it makes a lot of sense in just a moment. I'm going to show a problem that I had with it in the first place. The bolt liked to connect to the outside of the shell of the electrolyzer, basically grounding it out or causing it to short circuit, and making it where it doesn't produce bubbles, and give a lot of hiccups in that case, and also increased heat, and a lot of other things ended up melting pieces, plastic pieces, and a lot of other things. So we went through a lot of headache trying to make sure that that it was perfectly aligned as well, because lining the hole up with the piece was kind of hard. So I ended up using a bolt right here to and a nut to make sure that it was centered in the hole, and it just happened that the nut was the perfect size of the hole, so it ended up working out kind of perfectly, because you want to have a pretty wide circle for the bolt to go in on that end plate. You can see the nut that I put on the bolt there. I'm fixing to take it out. It's got a little bit of epoxy on it, and it fat in there pretty good, so I kind of sacrificed one. I got my hands a little bit wet, because you want to work this stuff with wet hands. Makes it a whole lot easier. And then I lined it up so it fat in there perfectly. And once I got it seated on there, I ended up using a washer to completely mush this stuff all the way into the plate, basically full sending it. And as you can see, my paint's is a little whacked up right here, but I end up repainting it after I've got it on the electrolyzer. So I mean, you can always fix that kind of stuff later, so it's better to worry about functionality instead of aesthetic. And especially in a part like this, it's got to be kind of perfect, so it doesn't arc or it doesn't have any sort of electrical problems, because this is where it's getting its power from, and this is what lets the electricity flow through each cell. So this part's kind of important. So now I'm going to ohm this out. I'm going to make sure that it's not connected to the outside shell. As you can see, this beeps, so that means electricity can flow through that. And if I take this prod and put it on the outside shell and the bolt, and as you can see, it's not beeping, so that means we've got no connection there. That's a good thing. This is just some cork gasket material you can buy at a local hardware store, and it's pretty easy to find, but this stuff is pretty good for holding in any sort of electrolyte mixtures, or for high pressures. And if you're wanting to run high pressures for torches or other things, these gaskets, I like to hold them on with a black Permatex or Forma gasket, whatever you guys call it. But this stuff is really good. Just don't get it on your clothes unless you want to ruin them. This stuff is really awesome for making the gasket material stick to the end plate. And I believe I let this cure for about 6 hours before I ended up putting on the plate. And you can see I'm spreading it around, making sure to get it all the way around all the bolt holes, because we don't want any leaks happening through those, especially. And as you can see, fits like a glove. Goes on there pretty good. And then I think I sandwiched it to it with C-clamps to kind of help it dry and to make sure that it's stuck. And the next step, I believe I put a little dab of epoxy. Yes, I put a little dab of epoxy on the end bolt right there because I was afraid that it might arc to that plate right there, and we don't really want that. So I used a drill to drill holes out and to make sure that they line up perfect, and then some bowls to kind of as a placeholder to hold them in place. And these worked pretty good. So, if you guys want to follow me step by step on how I'm putting these back together, it's a whole lot harder than it looks, but I make it look pretty simple. Now we have ourselves a 60-cell electrolyzer. This is a pretty large build in comparison to a lot of the other ones that we've made. We have some smaller ones, and I might make videos on them. You guys can comment down below, give me your opinion. These here are stainless steel ball valves, and I'm going to use these for the sight glass to help out with pressure, stuff like that. So I'm going to put a bunch of Teflon tape on them. And since it's metal on metal, I just use the Teflon tape. In a moment, though, I'm going to show a little bit of a trade secret, I guess, that seems to work really well for me. What I like to do is I like to take Teflon tape and go around plastic fittings when it's plastic to metal, and I use a little bit of black Permatex to seal it up, I guess, and make it a whole lot snugger in there, because a lot of these plastic fittings, especially right here where the sight glass is, you have to kind of turn it in at an angle where it may not be completely seated in there. Sometimes they end up at a funny angle, so basically you can see here I end up having to move it in multiple times, unscrewing it and screwing it back in, because sometimes these plastic fittings, they don't like going in straight, so you have to basically align them. Like as you can see there, I didn't tighten that in all the way. That's because it probably wouldn't end up at that specific angle, so it could have the hose slip on it in kind of a C shape, I guess, because the hose will go from one sight glass to the other, so we can see the exact water level inside of the electrolyzer. Right here for the sight glass, we're going to be using some clear nylon tubing so we can see exactly what's going on in there. And this stuff is great for any sort of backflashes that happen. I've had really good experience with it, so it's the one that I prefer using, but there may be a lot of other hoses out there that could work a whole lot better, but I'd say this gives a little bit of a window so we can see exactly what's going on. This is going to help us to know exactly how much to fill it up, because there's a fine line in between how high it is and how low it is. And since there's a lot of the HDP plastic in there, the plates, and just a lot of spacing, you use very little electrolyte, especially with a larger cell. And right here I'm going to use a zip tie to mark the level. And we've done a lot of testing and research with the level to see exactly how much hydrogen it can output. And about 3/4 of the way is decent. But right here it looks about half because the plates and the HDP plastic takes up a lot of space. And for our mixture, we're going to be using some sodium hydroxide. So I always recommend wearing full eye protection and some sort of a ventilator. I'm using like a fireman's gas mask, and the one I've got is pretty nice. I believe I got it used, and it was not easy to find, but it was definitely worth it in the long run, because this stuff, it likes to off gas, and I'll show you guys in a moment how much it smokes. This stuff is the electrolyte solution we're going to be using, and I don't recommend using anything else because you can have the production of chlorine and a lot of other gases when you're using anything else. And I'd say sodium hydroxide is the least of a hazard in comparison to a lot of the other ones like potassium hydroxide and salt and baking soda and a lot of other alkalines and caustics, because this stuff is it's not that bad to work with, but I always say use eye protection and use just be safe with this stuff, because we've worked with acids and these are the alkalines and caustics. And as you can see, it's very cloudy, and you can see a slight mist coming off of this stuff. And I stir this stuff until it's almost completely clear, as if there's nothing in it. That's about what you want to do. You want to stir it and let it sit outside for a while, because when it's mixing with the water, it's also going to let off quite a bit of heat. If you pour it in the electrolyzer right after you get done mixing this stuff and it looks foggy, it can tend to heat up the electrolyzer, and it might be a little bit of a scare, because if you're turning it on with those high temperatures, it may cause an explosion inside of it, because of the change of pressure and the change of temperature. So you want to be very careful with that. And I just leave this stuff out. You can see it's getting clearer as I'm mixing it, and you want to mix this stuff till it's clear and it's about like a warm room temperature. And I ended up leaving it outside and waiting for I'd say about 20-30 minutes for it to cool down before I ended up putting it into the machine. And the system is we let it off gas outside, but I ended up only using out of a whole gallon about three quarters of it, and you can see a lot of smoke rolling off of it right now, even after I've let it sit out for a while. But you never have to refill the electrolyte solution, so from this point forwards, I won't put any electrolyte in this electrolyzer. I'll just put water in it, and mainly just distilled water. If you put any other kinds of water in here, it can mess up your electrolyzer. And I know I've had a lot of skeptics commenting on videos, stuff like that, saying, "Oh man, that's not water, you put vodka in it, you need to drink this stuff." And I'm like, yeah, that's not going to be good for you. This stuff is not good for breathing. It's not good for getting on your skin. After this stuff dries up, when it's in its water form and it's been mixed with the water, it tends to look very chalky and white. And most of the stuff that I use with this caustic or electrolyte solution, I really recommend just throwing it away, because having it around could be a health hazard for animals or anything like that. So taking these things and disposing of them, whether it's taking them to the dump or or just getting rid of them in general, and putting them in a safe place where animals can't get to them, because this stuff is just not good to get on you. But you don't have to mess with it. It's a one and done deal when you're working with these electrolyzers, and I find that really awesome. The only reason why you'll have to refill this with caustic is if you have some sort of an implosion or an explosion with the electrolyzer. And as long as you have a good bubbler like this one here, you don't have to worry about that. I believe this one is made of a very thick steel on the inside. And I'm going to make a whole nother video on how this bubbler works and exactly how it's designed. And we've had no backflashes while using it. And it almost acts as just a shield for this electrolyzer when it comes to implosions, explosions, and vapors and a lot of other things getting inside of the electrolyzer. And I always fill it with distilled water just in case, but we've had no hiccups with it so far. And if you guys want to see a full video on exactly how I built the bubbler and was working on it, you guys can go ahead and leave a comment down below and tell me your thoughts. Maybe you guys have better ideas than me. I appreciate all of the good comments and feedback. And right now we're putting on the ball valves. You can see on this bottom elbow I'm fixing to turn it a little too much, and it's not going to be straight with the bubbler, so I end up taking it off and putting it back on. That's one thing with these plastic fittings. You want to be careful on how much you tighten them down, because they may not line up where you want them to be. And this sight glass for the bubbler is made of the same nylon tubing that I was using on the sight glass, and it holds up really good with high pressures. And we've ran torches on this thing, and the torches, you have to have between 60 and 70 psi worth of hydrogen and oxygen gas in the system. So it does a really good job. And you can put turn off switches and pressure valves, things like that, and automatic pressure turn off switches, and a lot of other stuff on this thing. And you can make it a whole lot simpler. But this is just the basic on how to build, the basic version of it. And this is the safest way to build one of these things. I do not suggest building just the electrolyzer and not the bubbler, because this thing is important. This thing is not just important because it protects the electrolyzer as well. This thing is really important because it protects us from any sort of explosions, because this stuff with hydrogen and oxygen, when they're put together, they're very, very powerful. They're one of the most powerful explosions on the planet. And they don't explode necessarily all the time. Sometimes they implode, depending on whether the gas is monatomic or diatomic. And there's a lot of variations in between each one. Just being safe with this stuff is really important. And like, see exactly what this thing's gonna do. I'm gonna turn it on right now. It's running off of a gasoline generator right now. You can hear the generator draw down a little bit because there's a pretty big load running on this thing right now. I believe it's running at some pretty high watts. I average about 20 amps on this thing. I'm gonna show my voltmeter and show exactly what volts we're running. It averages about around 20 amps, and we're getting about 90 volts DC. So if you guys want to see the math, here's the watts exactly, and that's how much being drawn off that generator right now. And that generator is a 3200 watt generator, so it's being drawn on quite a bit. Built up some pressure here, and I'm checking all of the I check everything. I only record me spraying the end cap here, but I check everything with soapy water just to make sure that we're not having any sort of bubbles leaking out. And you'll see some pretty big bubbles if it's leaking. It's running at around 29, 28 pounds of pressure, and you can see we've got the valve barely cracked open here, and we're getting quite a bit of bubbles. I'm going to make another video talking about bubbles and how many liters per hour you can get out of this thing, as well as a video about the carburetor we're using and a lot of other things. I'm going to make a whole separate video about the electricity and exactly what kind of wattage and voltage we're trying to achieve. I know this video is drawing out quite long, but I wanted to put as much information as I can for you guys. But anyways, this is the electrolyzer build. If you guys want to see more videos and stuff and you got a lot of questions, you go ahead and leave them down in the comment section below. I'm going to try to answer as many as possible. If you guys want to see more stuff like this, like and subscribe. I would appreciate it. I'll catch you guys in the next episode. Peace out.